I've always thought that game consoles have rather boring designs, but given the PlayStation 3 Slim is the only console I've ever owned, it holds a special place in my heart for ugliness. The PS2 at least had texture, but all the PS3 models have just been curved, meaning you can't put anything on top of them, and they've just generally felt boring. And not to say that the newer consoles are really any better, the PS4 was boring, and I think I genuinely like the design of my actual router more than the PS5. But since other people have already fixed newer consoles, and I don't even own one anyway, let's improve the PS3 Slim. Before I can even get to thinking about design though, I need to know what I'm working with in terms of how much space and shape the electronics take up. So I brewed up a nice pot of tea and cracked open my PS3. Because I wanted to know exactly what I was working with, I basically just followed iFixit's teardown guide with the exception of anything that would permanently damage it, just in case my idea didn't work out. Given that there's no sticker on this screw hole, it seems like someone else has been in here before. Another reason I hate this design is just how much it wobbles when you attempt to get it open. It's like it's trying to run away from being unscrewed. I eventually resorted to putting it on top of a pillow, and after that I was able to remove the blower fan, power supply, disk drive, and power button board. That left me with a nice collection of parts which I can now attempt to fit back together. But before I do that, I also decided to remove the top case of the power supply. Partly because this would reduce its vertical footprint, but also because I already had plans for a transparent top case. This was as simple as a few plastic tabs, and now I've got a nice exposed board with some mildly dangerous components. I also decided that even though I'm not the first person taking it apart, it probably wouldn't hurt to check on the thermal paste because chances are it's crusty. And boy was I right, this has definitely been here since 2009. So I gave an appropriate dosage of MX4 and clamped it all back together. Just to make sure everything was working, I also decided to just put it all back together sans case. This was really simple other than a few of the components ending up kind of wiggly because they were no longer screwed in place. But when I plugged it in, everything still worked fine. I did have a bit of a scare here because when I tried to plug in the HDMI output into my ATEM Mini, which is normally what I use for all my screen recordings with computers attached, I didn't get any output. Luckily, my Stanless Acer, which I found in a Portland alleyway, came to the rescue, confirming that everything still works. I guess it turns out that the PlayStation 3 does not like to output video directly to capture devices which label themselves as such. It's kind of a weird thing to think about in the age of game streaming to not have a console support a video capture card, but I guess in 2006 this was just the simplest DRM Sony could think of to keep people from recording their DVDs. But anyway, now that I know everything will work out of the case, I got to work with some basic measurements. One thing that was a bit of a surprise to me based off this weird dome shape is that all the insides fit together in essentially a perfect rectangular prism, with the exception of the top of this fan, which is a little bit convex. I went over quite a few kinds of designs, but in the end, I decided on these hybrid 3D printed sides sandwiched between laser cut front and top panels. This sandwich design also solved the issue of build volume for me, because the PS3 Slim is about 26 centimeters deep, but the side pieces were going to have to be printed vertically because of their heavily curved shapes. And unfortunately, all the 3D printers I have access to only have build volumes of 22 centimeters. So by using these spacer bumper things in the front and back, I can make the side pieces seamless. For filaments, I decided on this pink PETG for the front bumper parts because they are relatively thin but also need to be really strong. On the other hand, these sides are quite thick and rigid, so just some normal PLA was fine. I went with this nice marbled white look, which I also think goes really well with the top panel you'll see later. So I got to printing, and about 10 hours later, I was left with some minor stringing on the PETG, but almost flawless prints. Unfortunately, no matter what I tried with my designs, the front bumper pieces did have to be printed in two parts. In order to keep them sturdy, I built this bow tie kind of shape to have a physical bridge between them that wouldn't risk slipping out. To really make sure that my biscuit stayed in well, I dripped in a healthy amount of CA glue, lightly hammered it in, and then melted all the pieces together with a soldering iron. Next was the issue of holding the whole sandwich together. I needed a solution which could stand up to quite a bit of weight, but still allow me to disassemble the whole thing for later maintenance. Glue was obviously off the table, but fortunately I had these brass heat set inserts lying around for a previous project where I made handles for my bathroom drawers. These things are great because you can get really strong threads with just a little bit of heat from a soldering iron. So once all those had been added, I was ready to see if it fit together. Using my trick from the last time I had to screw through 3D printed parts when making the diskette case, I tightened my bolt just through the bumper piece to make sure it was aligned properly with the holes of the side, and repeating that for the 7 other screws. This left me with a surprisingly sturdy frame. All that was left was to make sure the electronics fit in, and yes. Throughout the assembly, you may have noticed these grooves on the side pieces. These are actually one of my favorite features because these days, what's a gaming related item without some RGB? So I soldered on some wires with DuPont connector leads to these lengths of addressable LED strips and stuck them to the inside of the grooves. But since these don't look that great by themselves, I printed some diffusers for them outside down on a textured build plate and then gently encouraged them into their slots. Because these are 3-pin addressable LEDs, they need a controller. I settled on an Arduino Nano simply because I have access to a decent amount of them, and they can run simple fast LED programs really well, which is what I'm familiar with using examples from. So I flashed a sketch which was much too fast, but does show that the strips work, so I'll revisit that later. Also, even though this wasn't actually intended, the way that these diffusers came out makes it really look like the individual LEDs are pixels, which is a really cool effect in something like this. So now that I know my frame fits together, it's time to start working on the bread of our sandwich, the front and back panels. The only problem here is that I don't pay for Fusion, and the free version does not allow exportation of your sketches or object profiles as any kind of 2D format. So unless I wanted to do a bunch of complex graphic design, I don't. And then also not be able to actually laser cut any of my designs, I needed to figure something else out. Luckily, Autodesk does let you export step files. I was then able to upload these to this website, select which axis to view it from, and it gave me a lovely DXF file which I can modify. Before I started doing any fancy patterns, I'll make a few prototypes out of cardboard which help me perfectly align all the cutouts for individual ports as well as the power eject buttons and drive slot. After quite a few prototypes with often 0.5 millimeter adjustments, I landed on a version where all the ports lined up perfectly. Unfortunately, all these painstaking adjustments were kind of for nothing, because while many of my prototypes, which were made out of this paperboard from LaCroix boxes, didn't block plugging things in at all, once I tried making one out of 3mm cardboard, which is a similar thickness to the plywood I would be using, it was just too thick and I could no longer plug in my HDMI cable. I guess it wasn't totally for nothing because while Fusion doesn't allow you to export DXFs, it is completely happy to let you import one. So I was able to use my measurements to make this printed insert, which is only about 1 millimeter thick, just perfectly allowing me to plug in an HDMI cable. With all my cuts finalized, I was able to start making some designs to be engraved. For the front panel, I ended up continuing with this swooshy theme because it tied everything together, and I also just thought it worked really well with the rounded side pieces. As a bonus, mostly out of pure luck, this whole pattern ended up really working well with all the holes that were in the front. Nothing ever is really interrupted in it, and even when it is, it's not misaligned, and so things fit in nicely. In the case of the power buttons, I had some vertical leeway, so I could place them exactly where I wanted to, but it was sheer luck that the USB ports and disk drive slot ended up lining up so well. I then did a similar thing for the back, but instead of having it go right up to the edge of the wood, it has a couple millimeter offset inwards. I also cut cardboard versions of the top and bottom piece to make sure they would properly slot in, and with everything fitting together, it was time to do the real versions. I was super happy with the way that my engraving on the front and back turned out, but I was mostly excited for that peel on the acrylic top. Nothing like a good peel. This is probably my favorite part of the whole design because everybody who loves nerd loves transparent nerd even more. So the combination of neat engraving and seeing all the electronics through the top, I think really fits this nerd aesthetic really well. I also went ahead and printed out the back port insert and glued it in, as well as this rectangle of gyroid infill which serves as the back vent. But now it was time to do something I had been putting off for as long as possible. In order to be able to turn the console on and off as well as ejecting discs, we need to be able to access this board, which contains their buttons as well as some indicator LEDs. And I tried pretty early on in this process to reverse engineer this board in order to use my own buttons or some other solution entirely. But alas, my electronics and PCB design skills just weren't there. This really felt like the point of no return for me because previously all the stuff I had done was entirely reversible. So unfortunately, I had to tear apart the existing board's face in order to use its buttons. I then glued in and stuck on my laser cut buttons with some simple double-sided tape. Before I closed it up though, I made sure to fix the obnoxious LED program, and after trying a few, I landed on modifying a version of the Fast LED Pacifica example with pinks rather than blues to match my pink pony bumpers. But now with all my pieces ready, it was time for final assembly. To finish off, I printed another gyroid grill in 2 pieces for the fan intake hole, added it in, and I think the whole thing looks amazing. Now all that's left is to power it on and... well, I guess my LEDs just aren't working. And come to think of it, I don't hear any hard drive noises or see any fan spin. It seems that at some point between when I disassembled everything and tested it, and now, something went wrong. Also, just for the record, I did try a bunch of troubleshooting steps off camera, just none of them were particularly interesting to watch. So if I do figure something out, I will either make a community post or a YouTube short or a something. So I guess subscribe. Hey, self-promotion. My guess is that it's related in some way to that power board, given the system won't turn on at all via any of the methods previously mentioned if that isn't plugged in. I know this feels like a bit of a cop-out to leave you with a broken console, but this video was supposed to be uploaded a long time ago. The original concepts for the project started before I even started thinking about last video, and the console had been disassembled and in pieces on my desk shortly after it was published. That's almost entirely due to being originally meant to be a sponsored video in partnership with a Chinese manufacturing company, but due to first multiple design modifications, budgetary constraints, and then the real end of the project, tariffs. I was lucky enough to gain access to a laser cutter again just days before I was going to scrap the project. If you want to make your own PS3 Slim case without ending up with a non-functional console, as usual with all my printed projects, there will be design files down in the description. And if you have access to a larger format 3D printer, you can also just print out all the side pieces with or without their swoosh designs, along with making your bumpers without biscuit bow ties. If you enjoyed, consider subscribing and maybe sharing the video with someone who would enjoy it. I guess I'll be back in another 3 months with another ill-fated project. Until then, have a good day, week, month, and survive the rest of the year. I'm not in the middle of the frame, am I? So I look like I'm either about to try to sell you something or complain about women. Read the script. Simple LED strips and stuck to them make this printed ear insert really simple, not really simply, you dumb fuck. That rhymes, and it was not supposed to.